So we're ready to texture with Copernicus, and as we said, we're going to create two different materials with two components, one for the side and one for the center. And we're going to start with the side ones. Basically, we want to create some basic dirt noise and add this grid pattern to use it with the normal map. So back in Houdini, I restored my viewport to the standard build one. I don't need the animation editor down here. And we were branching for the texture here after the UV layout. So first, let's take care of the side material. We want to drop down a copnet, not the old one, the new one. And let's call it TARS center. And we can set the default resolution, let's say, to 2K. There's no need for a 4K texture, it will be faster. And in Copernicus, you can always change the resolution later on. So you can set a lower resolution while you're working and then crank it up and export your textures. So let's dive inside the copnet, and in here, let's take a preview material right away so we can visualize what we're going to create, and a SOP import. Here we want to target the sides that are coming out for the texturing, so out sides for cop. Are we doing these sides or the... Oh, we're doing this side, so let me rename this one. I don't know why I called center. So this is the geometry, and if we plug it in the geo of the preview material, we will have the preview on this geometry. So basically, if we take a fractal noise and plug it here, we know that it's working. Let's delete it. So let's try to create the grid. And we basically did the division on the geometry, so now we can create that grid pattern following these lines as reference. So basically, we want to combine a bunch of lines, copy those lines, and use it to drive the normal map. We want to do it with an SDF shape, so take one, and let's visualize it. We want to set it as a line, so set it here. We want to add thickness, and we want to copy and paste the end and start thickness because we don't want some tapered line, so we can do something like this. We want something really small, so 0.001, so this, and we want to cover the whole length, so make it way more bigger than the UV space itself. Then we can convert it to mono, so take an SDF to mono. And basically, if we plug this line into the base color and preview the geometry, there should be a white line somewhere. So basically, we want to create a bunch of this and copy it on all the subdivision we have, so we can create that grid pattern. With this color will be quite hard to track, so let me temporarily take a mono to RGB, so we can set maybe this to a dark gray and this to a blue for now, so we can really clearly see where we are going to put those lines. And if you watch the SDF shape, right now it's in the middle. This is not ideal for us because the UV basically starts from the bottom. I want to create, let's say we have this line for now, so I can duplicate it 3 times and then duplicate the all 3 lines a bunch of time for each phase. So basically I want the first line start wherever the bottom segment is. So I want to go here, and basically I want to lower this value until it's somewhere here, and let me preview the mesh, and basically I want to lower it as much as I can until I have, you know, right now I'm going over the UV space, so I know that this is the bottommost face, so this is the right position for this line. Let me place it here. So now I can take a copy and transform, plug it here, and it will give an error because by default it gets the sides ref, but we need the shape input. So now we can translate it on the y-axis, sorry, 3 times. So 1, and make it really precise. and increase the copy to 3. So basically now we have one size, and we can take another copy and transform. The result will go in the shape and replace the result. And we can copy the whole thing. Let's place it nice, something like this. And if we increase the copy, we should cover all the sides. We miss one, and there we go. This basically are the vertical lines, and by bonus we also cover the top part in the right way. So let's create a netbox over here. These are the vertical lines, and my advice is when you're done with a few nodes of Copernicus, just close the preview. If you work with Touch Designer, we are very familiar with this kind of saving resources while working. So now for the horizontal, we will start from the top or the bottom, I don't know, but let's just duplicate the SDF and the SDF to mono. Let's replace this for now. And this time we want the other orientation, so rotate the line by 90 degrees. And we can reset the Y translate. This time we need to move with this translation on the X. So let's say we will trace the first segment. So let's place it here. And just as before, we want to copy and transform this line a bunch of times. So here it will go in the copy to transform. And we want to translate it like this with 4 copies, sorry. So basically we have this segment. Now we can duplicate it on the bottom and then add a middle line also. So take another copy and transform the result in the shape and replace the output. This time we just need a copy and where is it? There we go. We want to place it here. So basically this is the horizontals, but we also need to add one in the middle. So duplicate this guy and take a blend node so we can start to mix these lines. Since we're going to add white on white, we're going to use the screen mode. And I always take a little bit for granted how image manipulation work. Some of you made me notice that in some video tutorials. So I'm also planning to do some, intro to Copernicus stuff, which will go a little bit deeper in all the image manipulation concept. So stay tuned for that. For now, let's just take this guy, reset the translation, and place it in the middle. So let's see here. Or honestly, we could also transform this one, so we don't. Let's try. Let's delete this guy, take a transform to D. We want to feed from the mono, and this will be set to the foreground. And let's see, we just need to lower it until we hit the middle. So right here, let's close all these guys. And I believe we need to, we need to set the blend mode to screen, otherwise the single line will cover the other ones. So basically these were the horizontal one. So let's also blend with the vertical. So this will be the background, this will be the foreground, and this will be set to screen. So let's see, we just need to add this line on the top. And also, if we look at the reference, these little lines over here. So first, let's take care of this top one. Let's make it here on the horizontal one, since the other one were added in the vertical. So take a blend, and this time let's copy this guy. It will be on the foreground, and let's see where it is. So There it is. We need to place it here. Let's make it match with the lower one, something like this. Take a copy and replace the input. So we can copy it 2 times and then another one for the I believe yeah, of course they are working because they should be the other one below each other. So we are good with the top. We can basically close this preview and make another network box. These are the horizontal. I wrote it good, yeah. And just create the little ones now. Basically they need to be placed here and here. And I believe I forgot, yeah, to set also this to screen. So now we have everything except the little ones. So for the little one, let's duplicate this blend. This will be in the background, and in the foreground we will add the little ones. So let's duplicate another SDF shape, place it here on the foreground and replace it to the mono RGB. So let's increase the thickness so we can tell apart for a moment where it is. And let me display the SDF shape because I know that I need to start from also I don't need to be rotated this time. It needs to go in this direction, and we also want to lower the length. So let's lower it in the bottom left corner and let's see where it is. Okay, it's right here. Let's lower the thickness a little bit. And let's see what's the bottommost faces. Should be this one. Yeah. So 1, 2, 3, 4. It needs to be on this segment. So we want to lower it. And let's set the length to be something like this. Let's place it good and revert the thickness back to where was it? 0.01. Yeah. So increase the length now, something like this. And we want to place it on the most left part. As you can see from the reference, there are 1, 2, 3, 4 for each bigger segment. So this should be fine. Now let's take a copy and transform. Let's place it here. What's the oh, not the ID. And we want to duplicate it like this. So we do have 4 segments for each bigger square, maybe a little less. Now let's take another copy and transform, so we can copy this 4 segment over the whole length. I always make the wrong output. So let's try something like this and just increase the copy until we have everything covered. So there should be the right amount. So now we can tweak the distance with the translation. So let's say something like this should be fine. Yeah. Now we just need to copy it on the lower side. So a final copy to transform. And let's move it where? Here. Wow, I nailed it. So basically we have the whole grid. Let's create another network box. This is the little one. And basically we can create a null after the final blend. Let's call this out base grid. So basically all the pattern for the grid is done. So let's look at what we have. This will basically be some sort of alpha map to drive various ping. And maybe let's just add a contrast node before the null. And let's set it to 20. So we have a very high contrasted ping. Also, let's set it to clamp above 1 so we don't get overshoot values. And let's move everything forward so we can make some space. And let's disconnect the base color for now, and let's take care of the normal map. So we're coming out from a black and white image. Of course, this is not good for a normal map. So first we want to invert it, because whenever you're converting an height map to a normal one, the black value will be pushed in. So we want this to be inside the geometry. So let's plug it into the source of the invert. And this will be basically the height map that will be converted to a normal map. And to do that, we want to take a height to normal node. And if we display it, we have some standard normal map now. And lower the height scale, something like 0.1. Create a null. This will be the out normal. And let's plug it to the normal input of the preview material. So now we do have something like this. We also want to lower it here in the preview. So open the normal and displays tab, and let's set it to 0.1. Still too much, 0.02. I don't want to lower too much the value of the actual map, because we can tweak it. We can tweak the strength also in a real. But maybe let's just set it to be half of it, so 0.05, something like this. And for the normal map, we are actually good to go. So let's place it down here. And before taking care of the other map, also create a ROP image output. We will use this node to write the texture, so we can duplicate the null and the ROP image. Let's call this one normal. And we want to reference the null in the cop path. And here we are going to write the file name. And we want to write it in the UI project variable we created. So basically here will be inside the content folder, and we want to create another folder. We will call this text. So all the image will go there. And for the name, we actually want to take the copnet name plus the output. So this copnet and the one for the center, they won't get overwritten with each other. And to take the name of the copnet, we need to write a backtick op name, the path, which is just the parent, close the backtick, and we want to add the name of the ROP image output. So underscore $os.png. Let's middle click, and the file will be called TARS size normal.png, which is fine, and it will be put in the correct folder structure. So we can duplicate it with the null. Let's call this one base color, and also the null, so out base color. Let's replace the output, plug this into the base color, and this will be fed to the mono from the mono RGB. So for now we should have the blue back here. We need to change the color, but we have two map ready to work with. And before taking care of the colors, basically this base grid, which is really sharp, is fine for the normal map, but we actually want to distort it a little bit before feeding it into the base color. So after the base grid, let's take a distort by slope, drop it down, and as you can see, by default it comes with this slope direction. And even if we feed the distort, the grid into distort, we will get an error, because the distort by slope needs a slope to work with. And the slope is defined here, but also the slope direction to work needs some source to create some direction. So we want to take a fractal noise, not a fractal noise 3D. And if we plug it into the slope direction, you can see that basically this noise is creating a slope direction, which is something like this. Basically, this is a 2D vector which tells the image in which direction needs to be distorted. all applied in distort, we have something like this, which of course is too much for now. So first, let's tweak the noise a little bit. We want to, let's change the type to Perlin, and let's lower the element size quite a lot, something like 0.005. So we have a very small noise. Also decrease the roughness. We want some pattern like this for the distortion. Then let's look at the slope direction, which by default is very high to height. So we want to lower the angle to something like 30 and reduce the scale by a lot, something like 0.01. So we do have something like this. And finally, in the distort, we also want to lower the scale a good amount. So let's zoom in and set it to something like 0.003. I mean, we really want to blur it up in a dirt way, but very little. So something like this should work. And also, before setting the color, I want to invert this map, just because I think it's more intuitive if the dark and light parts correspond to the relative color, even if they won't be black and white, but at least. So this will go into the mono RGB, and let's preview it. So let's try to set the color, reset the ramp, and set it to maybe some dark gray value, something like this, and some light gray value. So let's say something like this. And let me look just at the base color. Maybe I want to add a little bit of blur here after the invert. So let's say 0.001. Yeah, I think it's better. Let's plug back the normal. And now we want to add some noise that we can use both on the base color, and we can also use for the roughness map. So let's start to combine a couple of noises. And let's see, we want to start from a very low one. Let's try 0.1, sorry. Let's also decrease the center so it will be darker. And set it to Perlin. I mean, when it comes to noise, it's always a matter of, personal preference, taste, aesthetic, and stuff. So right now I'm just creating some dirt maps to not end up with a clean texture everywhere. So this is really up to you. We want to blend it with another noise, and we want to set this into the background. Let's set the blend to screen and duplicate the noise. So this will go into the foreground, and let's tweak this other one. So this one we can increase the amplitude. So let's say 0.5, reset the center, and we want this to be a lower frequency. Let's say 0.1. Change the offset so it won't have the same output of this noise, and maybe increase the roughness a tiny bit. So altogether we do have this result, and basically we want to add this to the base color with another mono to RGB. So let's move this out of the way, duplicate the mono RGB for the grid, and plug the noise this time. So we do have this kind of mapping. And for this one, I actually want to create some, maybe gray, but with a little bit of dirt component in it. So I don't know, maybe something like this to something like this. So now we can take another blend node, and we can, this time maybe let's try with a multiply, replace the output. Let's see, we want to multiply these maps together, but maybe not this much. So let's say 0.7. Let's see what we have all together. Yeah, I believe it's pretty enough for this kind of variancy for now. And in the latest version of Copernicus, I don't think they were there in the starting release, but now we also have some preset noise and we can use it to create more variants. So if you go into the pattern grunge, you have these 5 noise, which are basically noise preset with a lot of noises layered one on each other. We want to take this layer noise and let's look at what we have. As you can see, by default it has a lot of controls. Let's try to tweak it a little bit. So change the offset just in case. And as you can see, by default you have a lot of controls for the individual element of the multi-layer noise. I would say that for me, maybe I just want to increase this frequency of the secondary noise a little bit, and maybe I will leave everything else as it is. So I can take another blend node, plug the background and the foreground, and this time I want to use the max mode. So basically only the maximum value of the underlying of the foreground will passing through. So I'm basically adding more light areas. It's just to add some little details, and this will be replaced to the mono RGB. So we do have something like this. Basically we added some more sharp variation on some areas of the texture. And so basically this is the noise. Let's create a network box. And now for the roughness, we basically need to combine the noise and the grid again. So for the grid, we actually want the dark part to be less reflective because, you know, this is went there over time. So we want to basically take from here, I guess. Let's take a null. Yeah, we want basically this, but full black and full white is too much, so take a remap. And here, let's see, it's going from 0 to 1 and remap it from 0.1, not 0.4, to maybe 0.6 or 7, something like this. And now we want to blend it with the noise. So take another blend node. This will be in the background and the result of the noise will be in the foreground. And let's see, try maybe maximum again. And we can lower the value to maybe 0.6. And maybe let's go and lower this blend value over here. So we have we can introduce this sort of behavior. Maybe 0.4 is a good value here. So basically I changed the amount of screening coming from the second noise. So let's also check what happened to the diffuse. Yeah, I think it's better this way. So we do have something like this on the roughness for now, which I believe is fine. Let's maybe take a final remap after the blend so we can control it further. And maybe let's decrease the input minimum so we have more shiner areas. So let's move this guy up here. Let's move also the normal part forward. Let's try to rearrange things a little bit. So now we can duplicate the null and the ROP, and this will be out roughness. Let's also rename the ROP and replace the input. So if we plug the roughness, let's see what it is here. We do have something like this. And also we need, I forgot, we need also to set the color space conversion for the ROP. This is not affecting the preview whatsoever, but it will matter when we will export the texture. So for the base color, we want to set the color space to sRGB texture. For the roughness, we want to set it to raw, and also for the normal map. We don't want any compression or color profile applied to the map that we need to use as raw data information, such as normal, roughness, and also the metallic one. And speaking of, we still have to create the metallic map. I save it for last because when you do the metallic, and you will see it, basically we want to feed from this guy. So take a null, and we can delete this one. Maybe we can organize things a little bit better over here. Let's reroute this guy so we won't have too much spaghetti in the setup. Basically, we want to use this as a metallic map without any variation, except maybe take a, where is it, the clamp node, just to be sure, and plug this, actually duplicate one of these again. This will be out metallic, and over here we want a row as for the roughness, and let's plug this guy here. So if we plug the metalness map now, and you can see the preview, this is why I left it for last. In viewport with the default headlight, the metalness looks weird because by PBR standard, basically a metal material is not dielectric and it doesn't reflect, it does only reflect values. So by default, it doesn't have any color information. But you can sort of some nice preview if you activate the one of these setting here. Like I can turn on the dome light and I do have some reflection now. I can maybe change it to 3-point lighting and you have some better result, but previewing stuff in viewport with the metalness is not really ideal. But the important thing is that this is the correct map we need to export to Unreal. Or rather, let me, we don't want to take from the blur. Whenever you are working with a metallic map and you have gray values, which are not full black or full white, you will have weird stuff happening. By principle, if you are working a metallic map like this with all sort of gray value, you are doing it wrong. A metallic map should be either white for dielectric materials or black for metal materials. So keep in mind that while you're working. Also, keep in mind that whenever you're compressing an image, some little amount of gray values will appear between the pixel, and that's why whenever you're working with a metallic map, you might end up with some tiny streak between the metal and non-metal part. So keep in mind that sometimes you will need to mask those little artifacts or to end up with some technique to resolve it, or at least don't see it in the final render. And we should be done with the material for the side, so we can select all the ROP output node and set render to disk. This should generate all the 4 texture we need. Let's quickly check in my directory. Where is it? UA project, TARS tutorial, content. The new folder has been created, the text one, and we do have the 4 texture.